Thanks for coming. Welcome to U of Ottawa Open House. I hope you're having a good day virtually. So my name is Professor Glenn Milne. I'm a professor in the Department of Earth and Environmental Sciences. And my job today is to kind of give you a little bit of background on our department, because right now you're making a choice of maybe what degree you want to study and where you want to go to study that degree. So hopefully some of the information I can give you today will help you make that decision. So you're here because you're thinking about, well, obviously coming to U Ottawa, but you're also thinking about learning or doing a degree in earth science in general. So that means hopefully that you're interested in the earth and how it works, the different processes that are happening on earth. For example, there's some pictures here on the left. So volcanoes, you're interested in volcanoes and where they happen and why do they happen. You might be interested in the landscape of the earth and going from mountains down at the bottom to major river valleys and why these things are created, how they evolve, the processes that make these things happen and evolve over millions of years. If you're interested in this stuff, then earth science and geology is a great degree to do. Also, a lot of people are interested in geology and earth science because they like the outdoors. They like to go out and spend time outside, and that is certainly something that a lot of earth scientists do in their work. So again, that's another good reason to do earth science. Or maybe you're interested in climate and the environment. Obviously, very important things right now as the earth is warming, so why? And answering all these kinds of questions, and protecting the environment. So all of these things fold into a degree in earth and environmental science. So if these are the kind of things you're interested in, that would be a great degree for you to do. So let me just start with a little plan of where we're going in the next 10 minutes. So I'll give you a very brief overview of our key programs, or like our flagship programs. And then I'll give you a few slides on teaching and research facilities, mainly teaching, because as undergrads, that's really where you're going to be. You're going to be taught things, but towards the end of the degree, you might do a research project, and so you get a flavor of doing research, and that's where research facilities, you'll get access to those. Field excursions, obviously, are very important of any earth science program, where you go out into the world's natural laboratory. That's kind of where everything happens, right? Then a little bit about our department in terms of the people. It's all about the people, including our students. And then finally, you're doing a degree to start your, as a springboard to start a career potentially in earth science and geology. So a slide or two at the end on employment related to this kind of degree. So so in terms of our programs, so there's basically we have three flagship programs, if you like. See if I can get my mouse to work. So these are three flagship programs. So we have geology, which is a kind of a traditional geology degree. We have environmental geoscience, and we have our geology physics degrees. They're all honors BSc degrees with specialization in these three topics. So geology is really for students that are interested in rocks and the solid earth. They want to go in and do a lot of field mapping outside. That's very much a typical geology degree. So that's really what that degree focuses on. Environmental geoscience is for students that are a bit more interested in the environment, more surface processes, hydrology, things like that, and monitoring environmental change and those kinds of things. And finally, our geology physics degree is more for students that are they like physics. They also like the earth. They're interested in earth science, but they want to do some physics, a bit more physics and math than you would get in these first two degrees. So if you like physics and math and you want to keep doing some of that at university, but you also want to apply that knowledge to earth science, then this would be a good choice for you. So there's a nice selection there of different degrees. And if you did want more information on that link at the bottom will take you to our web pages. I just want to do a new share quickly to show you. That'll take you to, make sure I get the right web page. Where is it? That's not what I want. Oh, I've lost my web page. Where did it go? Well, you know what? Let me just click on the link. Sorry about that. So let me just click on this link down here. And that's not working either. Oh, here you go. So hopefully you guys can see this. I think you can. It says it's all fine. So that's where you get to. Click on that link. It's our programs of study. You scroll down to the bottom, go to undergrad programs, and you'll see the programs that are listed on that slide, and you can click on any of these and get more information. For example, the suggested course sequence, it gives you a lot of detail on the courses that you have to take in any given year and courses that you have an option of taking. Right? So that's, if you want more information, that's the place to go. So I'm going to go back to my presentation. So feel free to take a look around on the website. That will give you a lot more information. I'll just get back to my slideshow. So there are degree programs. One last thing I wanted to say was they all have some overlap in some courses, but they're all a little bit different as well. So, you know, the core courses in each are slightly different, and they all kind of, so in environmental geoscience, you get more courses on things like oceanography and hydrology and things like that compared to your typical geology program. But you can still take some of these courses as options if you want, if you do the geology program. So there's quite a bit of flexibility. In terms of the structure of the programs, well, basically in first year, year one, so we're assuming you don't know anything about earth science when you come in, because it isn't generally taught in high school. So you get 3 introductory courses in earth sciences. And then you get also your kind of base science courses, chemistry, maths, physics, and biology. So that's kind of your building a nice base for everybody. And then in year 2, you start to learn more about the earth science stuff. You learn more about mineralogy, for example. That's what rocks are made of. You get sedimentology, structural geology, these kinds of, you get a little bit more specialized, but you're still kind of building a base. And then you have choices of doing other science courses. You might do more maths or physics, for example, and you have various electives you can choose from as well. And as you go through the degree program, you get more specialized, basically. The courses get a bit more advanced. The number of students in the classes goes down. You go to smaller class sizes. And you also get a chance to do a research project. So that's when you get a flavor of what it might be like to be a graduate student. Actually do a bit of research with a professor. Right? So that's basically how the degree is structured over 4 years. So teaching and research facilities. So most of our courses have a lecture component and a lab component. So the lecture component will give you the theory or the kind of key concepts, but then you go to the lab to kind of apply those concepts. And obviously an important thing in geology is looking at rocks. So you'll be looking at rock and mineral samples in laboratories. This is one of our laboratories in Marion Hall. This is a typical class, what it looks like in, say, first or second year. You've got your professor and you've got graduate students helping out the undergrads as they're trying to go through the exercises. So that's a nice space, a nice room with lots of hand samples and different things that we use to teach. Another room that we're quite proud of is our microscopy laboratory, because you know, rocks are made of minerals, and to really see what that rock's made of, we basically slice up the rocks, you put them under a microscope and you shine different kinds of light through it. You can see these images down at the bottom here, and that tells you more about what the rock's made of and its mineral constituents. We have a nice teaching room in Marion Hall also that has 20 of these research grade microscopes, and we run classes in that room for both first and second year courses, I believe, and maybe even higher level. So there's some of the teaching things we have on offer in terms of research. So this is a building that was built about 5 years ago now. It's called the Advanced Research Complex, and our department shares this with the physics department. And it's on King Edward Street. If any of you guys live in Ottawa and have driven near campus, it's a world-leading facility in mass spectrometry, and it's really focusing on research. So you won't really go there in the first kind of 3 years of your program, unless you do a summer research project with one of the profs, then you might get access here. But once you get to 4th year and you do a research project, you can potentially use some of the equipment in this building. So it has several state-of-the-art laboratories. It's used by our own professors in our department and actually other departments, and also colleagues in Canada and beyond in other countries. They send their samples here to be measured so we can send the results back to them. So as students, you will benefit from this, perhaps not early on in your degree, but certainly towards the end of your degree, you'll have access to these kinds of facilities. Field excursions are a huge part of geology. As I said, the outside nature is our laboratory. We're interested in how the world works. And so looking at rocks and taking measurements in lakes and rivers and other things, that's what an earth scientist does. And the first field excursions we start are in first year. So in first year courses, these general courses, we start right on our doorstep in Ottawa because there's some great geology in the surrounding region. So we take students out. For any of you that live here, you might recognize this is Hogsback Falls over here and here. So we take the students out to look at the rocks, make some interpretations, and understand the local geology. I think this one down here is along the Ottawa River, but I'm not sure, so don't quote me on that. But anyway, so you can see a lot of neat stuff locally, and you get that kind of stuff in our first year courses, the general introductory courses. And as you go through the years, you get more advanced field courses, and you kind of hone your skills. And for these courses, we go further afield. And it depends where. It can vary from year to year, but often we go to places like Death Valley in California or northern US. Some courses, we often go down to the Caribbean as well. So I think these top 3 pictures that you see here are taken from the Caribbean, I think near Bahamas. So we look at carbonate rocks made from corals, basically. And that would be like I think it's a 2-week trip, I'm not sure, but something like that. You go down there for a couple of weeks and look at the rocks and make interpretations and so on. We've run some trips to Iceland. I think that's so you can look at ice as well as geology and the rocks. And I believe this one is in California somewhere. So we do run trips in different places where there's interesting things to see, particularly the geology. So that's the outdoor laboratory. Field trips are a very important part of a degree in earth sciences. Our department, the main reason I wanted to show this slide was just to make the point that we have a thriving department. So we have a lot of students. We have 6. So this would be total number of undergrads at any time. It's around 60. Obviously, that will fluctuate through the years. We have a slightly larger cohort of graduate students. We have about 16 profs, 3 admin staff, and about 20 technical staff to run those research labs, mainly, that I showed you. The key point I wanted to make is we don't have a lot of undergrads. It's not a huge department. In some ways, that's a good thing because it means you get more attention. You get to know the profs get to know you, especially through the field trips. So it feels like, in a sense, like a big happy family. So it's a bit more of a personal degree in that sense in our department. So that was a point I wanted to make. So I'm kind of getting towards the end. So, finally, you go through our program. If you come here, you get your degree, then what? Well, this is just a continuation of a slide I showed earlier. So you go through your degree program. Let's say you go through it in 4 years, and then you basically get your degree, whichever one you pick. But the nice thing is our degrees are all accredited by the Professional Geosciences of Ontario, the PGO. And that's important because some companies prefer to hire students with a professionally certified degree. And so when you finish your degree, you can register with the PGO, and that will help you get a job once you've gone through the program. So at that point, you make it so if you do want to get a job and you register with the PGO, so then you go straight into a job with your degree. And I'll give you a list of typical jobs that earth scientists tend to get. Or you might decide at that point, I really like my research project, I want to do grad studies. So you can stay at Ottawa to do that. You can do a master's or a PhD, or you can go to a different university in Canada or even overseas. That's really your choice at that time. Typical jobs that geologists tend to get. I'm maybe going on a bit long here, but if you go through the geology degree, obviously you can be employed as a geologist. You might get employed by some exploration company in Canada that's looking to mine somewhere in the north. Then you'd be hired as an exploration geologist. Or if it's a petroleum company, you'd be a petroleum geologist. If you want to go a bit further in research, then you specialize a bit more, and you can become things like a sedimentologist, if you had a master's or a PhD. Or maybe you did more of the environmental side of things and focused on the ocean and oceanography, then you'd become an oceanographer. So there's a whole host of words here that describe what an earth scientist could be in terms of how they would call themselves once they become professionals. And so there's opportunities at all levels, going from BSc all the way up to PhD. So that's pretty much it. A very short tour of the department, virtual tour, and kind of the courses we offer. So, and I intentionally kept it short because we don't have, we're all kind of going along with a pretty tight schedule today. So At this point, I'm not sure how many people we have, but we're going to open the floor to questions. So if you have any questions that I didn't answer in the talk, now's your chance. Or if you can't think of anything now, you're welcome to get in touch later on. You can go to our website and ping us off an email if you'd rather do that. So yes, so does anyone have any questions? Okay. It's not necessary. But please go to our website, take a look around, and if you while you're doing that, if any other questions pop up, don't be shy to get in touch. You know, you can go onto our webpage, go under people, you'll find me. You can send me an email. That's perfectly fine. As I said, Glenn Milne. I'm in the department. I'm one of the profs. Yeah, so all I can say is good luck in making your decisions. I hope Ottawa is up there and you're in the mix, and hopefully what I've explained to you here will help you make the decision for where you want to go get your degree. So all I can say is good luck and all the best, and yeah, take care.